Hello, AP Statistics. This is section 12.2, nonlinear regression, which means you're going to have some diagram of points that will not necessarily make a straight line, meaning a nonlinear. Let's take a look at an example. Okay. First, in the past, you had stuff that looked like this. Y hat equals a plus bx. That was your linear model. Now you're going to have exponential. Okay. Most exponentials that you remember in the past look like this, like 2e to the x, where you had a number here, you had a number here, and then you had an input value for this x, okay, which is what you see here. And a power model almost looks like an exponential model. The only difference is that your base and your variable, which is a power, are reversed. Okay, so your input is now the base number, and you're going to have a standard constant for your power. Okay, let's look at exponential first. All right, and we're going to look at that school in Tucson. The population of cockroaches in Jason Patterson's Tucson dorm for the first 9 months of the school year is given by the following table. So we know what Tucson is like and their dorms are like, and this is the amount of cockroaches in the respective dorm room, okay, for basically a school year. Here's like you do. Take a moment, okay, pause this video, and I'd like you to plot these points onto your graph. Okay, now notice, okay, on your table that your output values, your y's, number of roaches, goes all the way to 555, okay? And the numbers in the very beginning are very, very small, okay? So you need to plan accordingly to make sure that your intervals are of the same length, okay? But you must fit or come close to fitting that 555 somewhere towards this top, okay? All right, please take a minute, hit pause, and we'll see what you got. Okay, so here's what I did. I counted by 50s, okay? And I know I didn't get quite to 555. For example, 500 is up here. But if I go one more bar, that's 550. And so I put my last point up close to that area, okay? And you can see that this is unique. This is not a linear representation at all, okay? You can't draw a line through those points quite easily. It looks very curved. It looks like it's increasing, but there is some shape to it. Okay, in fact, it does look like it could be exponential. So let's do this. Let's do some work. Now, think about what exponential means. And I'm going to draw this little picture here. Exponential means that it is increasing super fast once you go from 0 to infinity. Okay, and the x direction, it has a very strong increase. And what I'm going to do is I'm going to try to linearize this. Okay, and again, this is exponential. And the way you linearize any type of equation is by doing the inverse operation, okay? So for example, if this is exponential, the inverse operation of exponential is a log. And logs tend to look like something like that, okay? But remember, if they're inverse representations, that means that they mirror over each other with respect to the line y equals x, okay? And what does that suggest? Well, if I take the log of all these heights, what it should do is it should possibly give us an array of points that may form a line, okay? So let's test that. First thing I need to do is possibly, okay, pause this video again, okay, just so that you can input the values from your table into your L1 and L2. Okay, so this is my L1. I'm putting this in my big table here. This is my L2. This will be L3, L4, L5. We'll eventually get to. Okay, and so take a minute and put those in. Okay, and then once you do that, okay, come back and I'll tell you the new direction. Okay, take a minute and do that. All right, got them in there? Great. Here's what I got. I have L3, and to linearize my data, linearize. Okay, I'm going to take all the values in L2 and do the inverse operation of an exponential, which means I'm going to take the log of it. Okay, now there's two logs that we have. We have a log base 10, which is in your calculator, and then we have a natural log, which is basically a log of e base e. And so what you're going to do is for your L3, you're going to highlight it, okay, and hit enter. And in that spot, you're going to hit the log of your y's, which is your y's are in L2. Okay, so in L3, highlight it, hit log of L2. Number 2 is seconds, and the number 2. Okay, and in the end, you're going to end up with what you see here. Okay, in your L3, all those values. So check to make sure that those are right. And then here's what I want you to do. Okay, once you see all these in here, again, assuming you did these right, I want you to graph 2 of these lists. Okay, so what I'm going to have you do is graph your X's and basically your log of Y's. Okay, and I left this chart down here. This is a graph. Months, which are your X's. Okay, this is your L1. And I put number of roaches. I don't want that. I want the log of the number of roaches. Okay, so this will be your L3. So think about this. It starts at 0.301. It goes all the way to 2.7443. Think about what you want to count by as you go vertically, okay? And we will see where you finish off, okay? So plot those points, and I will get back to you in just a second. All right, so hopefully you hit pause and you work this out. Here's what I did. I filled in my chart, even though it's shown for me on my L3. These are all my log of L2s. They're listed from the lowest to the highest. Okay, I also marked my graph accordingly. Okay, so notice that I just counted by 0.3s because they seem to all be jumping by about 0.3s. Okay, or maybe a slightly a little bit more, but it seemed about like that. Okay, now here's what I want to do. I want to find the regression equation that passes through those points. It looks like that makes pretty close to a straight line. All right, so let's do this. Let's find the regression equation that passes through those points, and I'll do that on the next slide. Okay, and if you did your points right, it should look just like that. That's how your computer should do it. Okay, your TI-84. All right, so least squared regression line. We're going to do this for L1 and L3. Notice that these are all the values that you had before, and you're going to go back to the commands that we did last chapter. Stat. We're going to go over to calc, sorry, and then we're going to go to 8, which is linreg a plus bx. And then what we're going to do is we're going to input some different things. We're not going to do L1 and L2 like before. We're going to do L1 and L3. So let me adjust that real quick. This is L1. And put a comma after that, L3. Okay, and then again, you'll store this in Y1. Okay, so no comma here. Big mistake sometimes. No comma after the command. L1, comma, L3, comma, Y1. Or some of you have the inputs for those, and you know how to put those there. Okay, now, if you do this command correctly in your calculator, okay, you should get this answer. Okay, you'll get a linear regression screen like we've had in the past. Okay, and if you were to graph it, okay, it should pass through those points pretty nicely. Okay, but this is the equation of the line that goes through those points. Okay, so let me write it out. Y is equal to, and I will put a hat on it just like before. A is 0.01037. Okay, plus B, which is 0.30508x. Okay, X is equal to, let's see, we said X is over here. X is months. Okay, and your Y hat is equal to, well, let's see. It's actually equal to the log of the roaches. Okay, remember your Y was not just a plain Y here. It wasn't the roaches. It was the log of the roaches. Okay, so that's what I'm going to say here. The log of the roaches. Cool. All right, so that is your equation. Notice what I wrote here. This is appropriate. You may see this, okay? You may see the log of Y. Okay, that is not incorrect as well. I would say either one is okay, but don't double log it. If that's the case, then when you say the log of Y, That's just the number of roaches. Sometimes they'll do that. I feel like the way to my right is a little bit better. I kind of like it more like this. Okay. But sometimes they'll write the log here and then just say, hey, the log of y is the number of roaches. Which feels a little bit weird to me, but I like it more this way. Okay. All right, now what am I going to do with that? Okay, I found this good line. Okay, it passes through those points. That went away. Let me get it back. Okay, and what we're going to do is we're going to find a residual to see if that line actually fits those points well. Okay, so the way we find our residual from this old set of points, and let me go back to this, is remember what a residual is. It's how far these data points are from the actual line, and it looks like they're almost on top of it. But if I look microscopically, either there's some zigzag pattern, which I'm hoping for, okay, or there is some smooth curve, which says the linear model would not be best. Okay, so here's what I'm going to do. This is how you find the residuals. Okay, and if I go too fast, make sure that you hit pause if you need. Okay? But here's what you're going to do. Remember, residual, okay, is equal to y minus the predicted y. Okay, so now the y's that we're looking at with respect to our graph aren't really the real y's, it's really the log of the y's, okay, minus the predicted y hats. Okay, so they're the points that are on your regression line where you had a log of y hats. Let me rewrite that. That's not right. There's the log of the y hats. Okay, so here's what we're going to do. We already have the first part done. That piece is right here. What I want to do is find the predicted values for the points that are on the line, okay, that were on that previous slide. Okay, I'm going to draw that up here real quick. You had all these points that made this nice straight line, and I want all the points that actually fall on the line, not the ones that are slightly above it or slightly below it. Okay, and the way you're going to do that is you're going to hit y1, which is where your equation is stored, and you're going to input all the x values. Okay, so here's how it goes on your graphing calculator. Here's L4. I'm putting a little red box around it. Make sure it's highlighted, hit enter, and then you're going to hit Y1, L1. And for most of you, it is the alpha button, and then you have to hit the trace. Okay, that gets you this Y1 right here. For others, it's vars. Okay, then you have to hit Y vars. Okay, and you have to hit function. And then your Y1 will show up. Okay, but you have to get that there. And then make sure you use a parenthesis sign. Sometimes people use a time sign, and it's not meant to be multiplication. Okay, it is an input value into this equation. Okay, your one that's stored in your Y1. All right. If you get error when you hit this, it may mean that you forgot to hit Y1 on the previous slide. Okay, so make sure that that is there in that command. All right, so what you're doing is you're taking all of these x values, plugging them into y1, and when you do this command, you should end up with what you see here. Okay, so check your work to make sure that that matches that. Okay, and hopefully it does. Okay, that is this piece, that is your L4. Okay, and then your last thing you're gonna do is this, you're gonna take L3 minus L4. Okay, and that's going to be in this spot right here, L3 minus L4. And once you have that, these are your residuals. Okay, so take a moment. Okay, now that you have this, do your subtraction, your L3 minus L4. You can see that command is done right here. Okay, and hopefully you get all of these numbers. Okay, and once you do, you're now going to graph your L1 versus your L5. Okay, and you can plot these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, call those months. Okay, and then here over on the side is your residuals. Okay, and we will see what you got. Okay, so do me a favor, hit pause. Okay, let's record, assuming that you did all this part right. Let's put all these numbers here in these spots. Okay, and then what we will do is we will graph them. Okay, and you want to graph probably pretty small. Okay, notice that they're as small as, this is basically 0. It's just barely below it. Okay, it's basically 0. But 0.01, 0.018, these are tiny. 0.008, you may want to count by hundredths, okay, in each direction just to make sure you got it. Okay, I'm going to pause that and see if you can get me an answer or a set of points that look kind of like mine. Okay. Okay, so as I input these in, okay, I loaded all my items in here on my chart, which you have on your paper. Okay, I know they're already right here, and I'm just writing them down because it just helps me organize my thoughts better in terms of later on when I want to try to do this problem on my own, or if I'm doing a homework problem, I may not have all my work written in, and if I don't have all my work written in, I may not remember the process of everything. Okay, sometimes when you get to a full calculator and you see just all the stuff, you're like, how did I get all this? Okay, so this kind of helps you remind yourself where all these things go. Okay, now as you look at these plots, okay, I just counted by looks like 0.001 in each direction. Okay, maybe I should have just done 0.01. That would have been better. So 0.01. Yeah, 0.01 in the negative direction. As you read this from left to right, okay, you can see that your points, I'll get a different color here. As you read them left to right, it kind of bounce back and forth. Okay, so it looks kind of like there's a zigzag. Okay, in fact, when I had my graphing calculator graph L1 versus L5, okay, it gave me something that looked like this. Okay, maybe I forgot those points on the previous page, but it looks like that. Okay, so definitely a zigzag pattern, and that is great. Okay, zigzags are good. Okay, and what does that mean? Well, since the residual plot, I'm going to write this on top. And this is important. This kind of answers our entire question. Because our residual plot had a zigzag, okay, that means the linear model, okay, was appropriate. Okay, for my x's, which in this case was months, okay, and the log of y's. Okay, in that case, it was the log of the number of roaches. Okay, you'll oftentimes see these reversed with the word versus in between. Okay, and that's cool too. And because that model is good, all right, that means the exponential. Try to save that, but I couldn't. Okay, is good for the original values. Okay, so our residual just says that, you know what, the line that we tried to model for the months versus the log of the roaches was fantastic. Okay, in fact, not only did it make a zigzag, which is really the more important part, but your R was actually really good. I'm going to skip back just one or two because I want to see what it is. Yeah, it's 0.999. Okay, you can see it right here. 9998. Okay, so yeah, your linear model was really, really good, largely because of the zigzag of residuals, which in turn means that your exponential model is great for your original set of points. Okay, now what does this do for us? Well, it says predict the number of cockroaches there will be in 1 year. Okay, so I need to input cockroaches in for a year. Now, if you remember what your model was that we found, it was, let's say scoot back a couple, it was this guy. Okay, it was y hat equals 0.1, sorry, 0.01037 plus 0.30508x. Okay, so let me write that down real quick. Y is equal to 0.01037 plus 0.30508x. All right, so here we go. Y hat is equal to 0.01037 plus 0.30508x. And let's include everything here. X is equal to months. And Y is equal to number of cockroaches. And it's actually not that, it's the log of the cockroaches. Okay, log of the roaches. Okay, so here's what I'm going to do. I'm going to take the log here. This is actually the log of y, is what we're looking at. This is the log of the roaches. If I'm going to put this incorrect, grab my 7. Okay, and then what I'm going to do is input the x. Okay, now it says in a year. Year, 1 year, ooh, 1. Should I put 1 in here? No, you're right, because it's not years I'm talking about. I'm talking about months. That's what all these x values were. Okay, so if I know that a year is the same as 12 months, then what I would do is I would plug in 12. Now, if you have your y1 stored, you can just do this. You could say, hey, y1 of 12, okay, and it'll give you an answer, okay? And so what I'll do is I'll say the log of y is equal to, and we'll just plug in any way you want, really. Okay, we'll plug in 12. And so I will do the same. Now I have this stored in y1, I believe. So when I do this, let's see, I'm going to just plug it in. And let's see, 0.01, darn it, 0.01037 plus, mine wasn't working. Okay, now mine is a rounded answer, so probably won't look as clean as yours, but I'm going to get something that looks like this. I'm going to say the log of y hat is equal to 3.67133. Okay, and yours is maybe a little different if you use this little shortcut. Okay, now the last thing is this, is that I just did the log of y hat equals this. Okay, now after 12 months, I have more than 3.67 crickets or roaches in here because we had 555 after 9 months. Okay, so how do you get rid of the log here? Well, when it's a log, what you do is you take 10 to this power. So 10 to the log of y hat, and you'll do the same thing here. It's 10 to this number then. Okay, and that'll tell you the predicted number of roaches. Okay, and I'm sorry, I backtracked, darn it. Okay, so 10 to this answer is, if I did this right, 4,691.697. Okay, now that's what I got from this rounded piece here. Okay, had you done this, okay, just by using this shortcut formula, then you would have gotten something that's a little bit more exact than what I have. Okay, but it should be pretty close. Okay, which is a lot of cockroaches after that short amount of time, which is just a year. Okay. All right. Hopefully that all made sense. There's a lot of pieces of that. Okay. Now, as I scroll to your homework, okay, and it's right here. Okay, it's actually not as far as it should be. Here's what you have to do. You just want to do the first 5 here. Okay, this is exponential. Okay, These are for the next piece, power, and I will give you a brand new video for that, okay? But only do those 5 for exponential, okay? So after you do this, look at this video, stop, try those 5, see how you do, and then don't even consider looking at the power one until you're done with this first one, okay? That's just the way I would do it. My best suggestion for practice, okay? All right, if you have any questions, you let me know, and again, I hope you have a great day.